Good evening, guys. Am I audible?
Yes.
So what was the last topic we were discussing yesterday? We were doing some problems, right?
Yes.
Please put all your mics on mute. Keertan, are you there?
Yes, sir.
Please make me the host. Just click on my name and make me host. Yeah, got it. Thank you. So what was the last topic we were seeing, guys? I remember solving a problem.
We were doing the book back exercise 4.13, sir.
Okay. Opening. Yeah. So we were doing a problem based on shortest distance and this thing, right? Shortest distance and shortest time. Okay. Yeah. So there is a problem we were doing. 4.13, right? You guys remember this? Is there any doubt? I think I've completed this problem. That's what I needed to see here. We got the final answer as 0.75 kilometers. Is there any doubt that you guys have? Okay. We'll move on to the next concept. That is the last concept left out in this chapter, which is uniform circular motion. Okay. So write down the heading as uniform circular motion. Changing the software. See, listen. What do you mean by uniform circular motion? The first place, you guys know what a circular motion means, right? So what do we mean by circular motion? I want to show you a small demonstration of how to visualize it. I hope I'm visible, right? Now, there is one thing I'm telling you, if there is no response, I will not take any interest to teach anything extra. I'll just read everything. Okay. Let this be the last warning. The class is going down very slowly in terms of response. It's going to be like this. Don't expect any kind of extra interest from me to teach anything. When I'm asking, I want response. Am I clear?
Yes, sir.
Yes, sir.
Yes. I want response. Okay. Listen to this carefully. Now, see, I have an object. I took some random charge here, this cable. Okay. So I have something like this. Now, if I drop this object, right? If I drop this object, then how is it going to travel? So if I ask you to describe the motion of this object, what will you say? It is going to be rectilinear motion. It's going to be a linear motion due to whom? It is happening due to the gravity force. Correct? It is happening due to the gravitational force. Now, if I put this charger like this, okay. So if I have this charger like this, and let's say I strike it like this, okay. I strike it on the table in this way. So what is happening? So what will be the motion it is going to have? So if I give a velocity in this direction, okay, visualize it. If I give the velocity in this direction, then the object continues to move in this direction. Am I right? Right? I'm giving the velocity in this direction and the object continues to move in this direction. Now I have a question. What if I give the velocity to the object by connecting this wire? Let me connect it. So I've connected this wire and I'm giving velocity to this object. Right? What is going to happen? It is still going to move in a straight line path, irrespective of whether this wire is there or not. Am I clear to this point?
Yes, sir.
Now the important question is, what if I keep it like this, okay, and I hold it at a particular point, okay, I hold this at a particular point and give velocity to this charge, to this white color portion. Do you think it is still going to move in a straight line path?
No, sir.
No, sir.
What do you think will happen?
Sir, it will try to move in a circular path.
It will try to move in some curved path. We don't know whether it is circular or parabolic or whatever. It is going to definitely move in some curved path. Correct, Ada? Are you able to understand what I'm trying to say?
Yes, sir.
Yes, sir.
Right. So, 1 minute. Actually, I cannot hold both. Yeah. So, observe. If I give velocity, you are able to see it is moving in a path like this. You know what exactly is happening there? Can you think of the physics that is happening this? Let's try to draw the diagram on a paper and understand what exactly the physics involved behind it. Right. Now see, if I have an object which is given a velocity, linear velocity v, it continues to move in this path. Continues to move in a straight line path. Accepted? Right. Whereas, if the same object is given a linear velocity by connecting it to a string like this, then what will happen is there will be a force which is pulling this object towards the center of this kind of a path called as a circular path. Right. So what you guys told is right, it is circular path only. So it will take a circular path in such a way that there are two kinds of circular motion that are possible, where one of the circular motions can be called as uniform circular motion and the other can be called as a non-uniform circular motion. Clear, guys? So these are the two possibilities, but the context that we are going to discuss now is the uniform circular motion. Okay. Guys, am I clear to this point? Now, we need to answer certain questions. Okay. So let's see. What are all the points? So please write it down. Can you guys guess what will be the names that a uniform circular motion will possess? First of all, what do you mean by uniform in the case of a motion of an object? So wherever you see the word uniform, what comes to your mind? We have already learned something called as uniform motion. So what do we mean by uniform?
Constant, sir.
It is constant velocity, or we can say zero acceleration, right? This is the uniform motion with respect to a linear motion, right? Now, what is a uniform circular motion? Here also uniform has something to do with constant velocity. Rather, I will not use the word constant velocity, I will use the word constant speed. Okay. I'll use the word constant speed and zero tangential acceleration. So these are the two important things to be understood. Means when you have a particle which is moving in a circular path like this, okay, where this is radius and this is also radius. And if you are able to think of an angle that is getting subtended at the center, then this kind of a motion is what is called as circular motion. Then this angle is what is called as the angular displacement. Okay, the angle that the arc is subtending at the center of that circular motion is what is called as angular displacement. Okay, that is the first point. Second, so theta is equal to angular displacement, and generally it is measured in terms of radians. Okay, angular displacement is measured in terms of radian. Okay, now if I take the arc length AB as S, okay, then tell me guys, what is the definition of radian from trigonometry? So radian is defined as the ratio of arc length and
Radius.
you guys know this, right? So theta is equal to, can I write it as S divided by R, where I can write S is equal to R theta. Now, this is the relation between the linear and the circular parameters. Okay. So S is equal to R theta is the first relation that we need to understand. Am I clear, guys?
Yes, sir.
Right, good. Now, if I differentiate on both the sides, I will get ds by dt is equal to d by dt of r theta, that is r into d theta by dt. Correct? So what is this ds by dt called as? Is this not the velocity of the object? So velocity is equal to r into, what is d theta by dt? This is called as omega, where omega is called as the angular velocity, and this v is called as the tangential velocity. So let me show you what I'm trying to say. So first make a note of this point and let me know. I'll explain it in terms of diagram. Let me know if you're done, guys.
Sir, differentiation of r theta is r.
Sorry, differentiation of
R theta.
okay. No, R I took it out because radius is constant. No. See, if I give you d by dt of 5t, what will you do? You will take the 5 out. No. 5 into d by dt of t, which is 5. This is how you differentiate. In a similar way, I took that r outside and I wrote d theta by dt.
Okay, sir.
Am I clear? Okay, let me explain it with respect to diagram. Okay. See, if you remember in parabolic motion itself, I would have told you one thing, that wherever you have an object moving along a curved path, okay, and if anybody is asking you to calculate the velocity of the object, then the velocity of the object is always a tangent to the curve in the direction of motion. You guys remember this point? So velocity of an object, velocity means speed with direction, right? So velocity of an object is always what? Is always in the direction tangential to the surface along the direction of motion. Okay. So if suppose the object is revolving in this direction, let's say it is revolving in the clockwise direction in a circular path, I've taken a small sector. So small sector is obviously going to have an arc, and this distance we called it as S. So if at any instant you want to measure the velocity, you draw a tangent at that particular point, and the object is set to revolve with an angular velocity omega. So what is angular velocity, guys? So angular velocity is defined as the rate of change of angular displacement. So rate of change of angular displacement is what is called as angular velocity. Like how you call linear velocity as the rate of change of linear displacement. Angular velocity is the rate of change of angular displacement. Tell me one thing, is there any doubt in the terms that I've used till now? Is there anything that is confusing you? Am I clear?
No, sir.
Everything is clear?
Yes, sir.
Now the question is, if you are able to say, if you are able to differentiate the second equation with respect to time, differentiate second equation with respect to time, then what will happen, guys?
So we'll get angular acceleration.
dv by dt is, let's see, dv by dt is equal to r into d omega by dt. Okay, this, what is dv by dt called as? It is called as acceleration, and d omega by dt is called as angular acceleration. Good. So now you guys defined what is angular acceleration. It is the,
Rate of change of angular velocity.
that's it, simple. So it is the rate of change of angular velocity. So dv by dt, I will call it as a. A is equal to r alpha. So which velocity did you differentiate? There is only one velocity. That velocity is along which direction? It is along the direction of tangent. So this acceleration is called as the tangential acceleration. This is the point many people miss to understand. Okay. So you can ask me, sir, why are you using the word tangential acceleration? Is there anything other than that present? Yes. So with respect to an object in a circular motion, you need to be very, very careful, because there are two types of acceleration that are possible. One is called tangential acceleration, and the second is called as radial acceleration, or we call it as centripetal acceleration. That is what our main concept of discussion is going to be now. Okay. So I want you all to concentrate. It's a slightly tricky concept, but you'll understand.
Can you scroll up?
Yeah, sure. Any doubt?
No, sir, I'm just copying the equation.
Okay. Okay. Good.
Sir, do the
Yes, sir.
dimensions change of acceleration and angular acceleration?
Can you repeat the question? I didn't understand. Can the direction?
And dimensions, sir.
Oh, you're asking the dimension? No, obviously they are not the same. Because angular displacement, yes. Angular displacement is measured in what unit? It is measured in radian per second. Correct? Then angular velocity will be, when it is the rate of change of angular displacement, d theta by dt will be in terms of radian per second.
Yes,
Correct?
sir.
Then what will be the unit for angular acceleration? It will be radian per second square. Whereas tangential acceleration is measured in meter per second square. Obviously, the dimensions cannot be the same, because meter is related to linear motion. Radian doesn't have a dimension at all.
Yes, sir.
Correct? Yeah? Good. So this is tangential acceleration. Now I'm going to speak about something important. Please pay attention. Okay. I told you, right, when we did that small activity or whatever it is, I told you that when the charger was hit with a velocity v in the direction exactly perpendicular to the string, then there was a force that was acting towards the center. What is that force? You learn it in next chapter. As of now, I will tell you the word. You need not worry what it means. It is called as tension. Okay. So there was a tension that is acting along the string. You guys know what is tension, right? You would have seen it. See, generally in your home, you will have something like this, right? Where you will where your mom will dry the clothes, right? Once they are washed, they put it on a string, right? Or whatever it is, if it is there. But you guys would have definitely seen this. If I take, or else you take a guitar, for example. So if you would have observed a guitar string, right? It is fixed at both the ends, right? So when you plug this guitar, the sound is going to come, right? So tell me whether in this case or in this case, the guitar string will be able to produce a better sound. Is it in the first case or in the second case? You can guess.
First, sir.
First.
Why? Because it is held, in layman's language, it is held tight, whereas here it is loose, right? So in terms of physics, you will say that there is more tension here, and here the tension is this. So tension is a force that is related to the string. Okay, string, or you can talk about the charger wire, something like that. An elastic material, basically. It will have something called as tension. So I hope you got some idea about what is tension, right? So this tension is the one which was trying to pull the object towards it. So when the force is acting in this direction, why didn't the charger move in this direction completely? So we know the fact that in whichever direction we apply an unbalanced force, the object starts moving in that particular direction, correct? But my question is, you apply tension here, that is a force applied by the string. Why didn't the charger, that white color part, move completely in this direction?
Sir, because it
Rather,
was held at one point, sir.
had it been held, yes, right, would have been pulled. But that's not the right reason. Held in a meaning, held is like it is kept stationary. I've given you the hint.
Sir, can we say that the charger is also applying an equal tension in the opposite direction?
No. There is nothing. No. It was not able to come in this direction because of this velocity. There is an important connection. See, for example,
Right.
let's take an object which is dropped from a certain height. When I say dropped, you have zero initial velocity. So the object is falling down due to the weight mg. Acceleration due to gravity is pulling. You guys know what is it? Force is mass into acceleration. So the acceleration due to gravity is g. So it is mg. I hope you have no confusion with mg, right? Whereas when the same particle is given a horizontal velocity, let's say from the top of a tower, will the object fall down in the straight line path, or will it take a curved path?
Curved, sir.
It is taking a curved path, and that curved path is what we called it as parabolic path, right? So this is also motion in 2 dimension, and in this context, what is going to happen is the object is still going to take a curved path because there is a force acting like this and velocity like this. The important thing that will happen in the case of an object moving in a circular path is the velocity of the particle at every instant will be perpendicular to the force that is acting from the center. Okay. So this tension is there. No, so the object is going to move in such a way that at this point also there will be a tension acting towards the center. You take at any instant, the tension is going to be at the center and the velocity will be tangential like this. You're able to understand? So, if this kind of a motion is able to exist where the velocity and the force that is acting to the center, which is technically called as the centripetal force, are always perpendicular to each other, then that kind of a motion is what is called as a uniform circular motion. So there is only one motion in this world where the force and the velocity are always perpendicular to each other. What kind of a motion is that? I'll give you two options: circular motion, uniform circular motion. Which one is right?
Uniform circular.
It is uniform circular motion. Never write it as circular motion, because circular motion is broadly classified into how many types? Two types. So you're able to understand? So there should always be some kind of an electromagnetic force or some kind of a mechanical force also, for that matter. There should always be some kind of a force which is always acting towards the center for an object to be in circular motion. And what is the name of the force which is acting towards the center? It's called as centripetal. Center. So the name is, if you try to break it into two parts, centri is derived from the word center. This PETAL means seeking. So any force that is seeking towards the center of the motion of an object is called as centripetal force.
Sir,
Tell me.
sir, even if we do not provide any force, so there was no velocity, so the object, like, even if there was tension, the object still did not move towards the center. Right?
Object will, I never told object will move towards the center. I never told object will move towards the center. I told this force is the one which is responsible for the particle to move in a curved path. So I'll just conclude this, okay? So what I'm trying to say is, let us say there is a car, or let's say there is a let's say there, and you try to give the velocity to the car in this direction. Okay, it continues to move in a straight line path. But to the same car, if you wrap it around the string, and let's say there is, so you're sitting here and there is a person sitting here. Okay, your friend is sitting here and he is holding the string. Okay, if suppose you have the remote in your hand, right? It is you and it is your friend. Okay, you have the remote control in your hand and you're trying to give the velocity in the forward direction. So the car will tend to move in the forward direction. Now what your friend is doing is, immediately he's taking the string and holding it tight. So what will happen is, as you keep, you will not change the direction of velocity in the remote control. You'll still hold it in the upward direction. But to your surprise, what you will observe is the car will no more move in a straight line path. Rather, it will move in a curved path. And the reason is your friend applying a force towards himself. Okay. So what I'm trying to say is, to any object that is moving, if you exactly start applying a force in the perpendicular direction, which direction? Exactly in the perpendicular direction at every instant, the object will start moving in a path which is called as a uniform circular path. So, Bridget, did I answer your question?
Sir, no, so what I asked was, if there was no velocity, then still the object wouldn't move towards the friend.
There is no velocity. Yes, it would have moved, provided you apply force. If force, unbalanced force is there, object will move. That's what you learn in the next chapter.
Yes, sir.
Got it? See, the best example is this thing only. I didn't give a velocity to the object, right? But still it is moving because there is an unbalanced force, weight acting in the downward direction. Maybe if I had a string and I hold it tight, then what would have happened to that stone? it will be at equilibrium. Right? So that is what I meant.
Yes, sir.
Guys, am I clear till this point? Is there any other doubt you guys have? Is there anything else you want me to explain? I'll do it. Because this is a very, very important concept. It is not restricted only to this chapter. You will apply it at many places. Any other doubt, guys?
Sir, what is the difference between tension and force?
Tension and water?
Force.
Tension and force.
Yes, sir.
Tension itself is a force. It's an electromagnetic force. See, tension is a force only. It's a different name. See, for example, how do I say weight? How do you define weight? If somebody asks you what is the difference between do you guys know the difference between mass and weight?
Yes, sir.
Yes, sir.
So you stand on a weighing machine, right? Actually, are you seeing your weight or mass?
Weight.
That's what, because the name of the machine is given as weighing machine, we think it is weight. It is showing the mass. Because mass is measured in kilogram, weight is measured in Newton. This is where the main problem starts. So if somebody asks you, what is your weight, see, let's say you're 50 kilograms, your weight is not 50 kilograms, your mass is 50 kilograms. What is your weight? Your weight is 50 into 9.8. Your weight is measured in Newton. So weight is the force with which the object is being pulled towards the earth. So weight is also
Yes,
a
sir.
force, but the technical name given to such kind of a force which is acting due to gravity is called as weight. In a similar way, tension is also a force. So if there is a force which is acting or exhibited by elastic materials, we call it as tension.
Fine, sir.
I hope it is clear, right?
Yes, sir.
Yeah. So I wanted to tell something. I forgot. 1 minute.
Sir, could you repeat the statement for uniform circular motion?
Uniform. Please write it down. So if the velocity and force are always perpendicular, actually, see, wait. One small correction. What I need to define it in a different way. That is a condition. What I'm saying. Please write down the definition for uniform circular motion. Okay. So listen, guys. So we know that circular motion is when an object is moving in the path of a circle. That is a very simple thing, right? So this is angular displacement. If the particle is revolving in anti-clockwise direction, I'll call it as angular velocity, and the particle is also going to have angular acceleration. Correct? Now, what were the relations? S is equal to r theta, V is equal to r omega, A is equal to r alpha. What does this A stand for? This is called as the tangential acceleration, right? So for a particle to be called, for the particle to be set in a uniform circular motion, the tangential acceleration is the one that is supposed to be 0. So please write down the definition in this term. So an object which has 0 tangential acceleration, in the bracket you can write it as constant speed. I'll tell you why I use the word speed. Okay, an object which has 0 tangential acceleration, in the bracket write it as constant speed, is said to be in a uniform circular motion. Am I clear, guys? Okay. And an important note that you need to make is, in uniform circular motion, force, that is centripetal force and velocity are always perpendicular to each other. Centripetal force and velocity are always perpendicular to each other. Each other at every instant. Clear this? Is there any doubt other than this? Is it clear? Shall I proceed?
Yes.
Now listen. I told you that there is something called as centripetal force, right? So centripetal force means there is the force which is acting towards the center of the circle. Correct? Huh? So if there is a force which is acting towards the center of the circle, we call it a centripetal force. When force is not equal to 0, can I say acceleration is not equal to 0? Because what is force? Force is mass into acceleration. So m into a is not equal to 0. Mass cannot be 0 for an object, right? So acceleration is not equal to 0. Then if the force which is acting towards the center is called a centripetal force, then what can I call as the acceleration which is acting towards the center? We call it as centripetal acceleration, or this is also called as radial acceleration. It's called as radial acceleration. So both mean the same. So an important point to be noted here is in uniform circular motion, tangential acceleration is 0, whereas the centripetal acceleration is not equal to 0. I can write it like this also. Centripetal acceleration is equal to radial acceleration is not equal to 0.
Sir,
Whereas in non-uniform circular motion, what will happen? Tangential acceleration will also be not equal to 0. Centripetal acceleration or the radial acceleration will also not be equal to 0. Yes, somebody was asking. Is there any doubt?
yes, sir. Sir, so in free fall, the centripetal acceleration is the gravity.
You don't get confused. Centripetal abdinale center. Free fall is linear motion. Linear motion, there is no center. So what I'm trying to say is, you use the word centripetal only for one kind of a curved path. What is it? Only for one kind of a curved path. Center is present for which object? For a circle. So don't get confused. For free fall, we don't use the word centripetal acceleration.
Okay.
Okay.
Sir, I have a doubt. Sir.
Tell me.
Sir, could you give an example of non-uniform circular motion?
Non-uniform circular motion, see. Okay, first I'll give you another example of uniform circular motion that you have learned in your chemistry. Let me see if this is clear. See, you guys have learned atomic structure. So I hope you would have learned this chapter, right? In chemistry.
Yes, sir.
Yes.
Right, at least in your 9th standard also you would have learned. Right, there are different models of atoms, right? One is Thomson. Then you have Rutherford. So each one had their drawbacks based on which certain theories were proposed, where we are following the Bohr's model of atom. Right. So what did Bohr say? Can someone tell me? So Rutherford told that there is a central part called as nucleus, and around this nucleus, what did Bohr say? There are orbits in which there are electrons revolving. I hope you know this, right? So these orbits are in what shape? What orbit did he say? Did he say circular orbit or elliptical orbit?
Circular orbits.
So circular orbits. Okay. Here also we are discussing about circular motion only. So let's say the electron is revolving in the anti-clockwise direction. So its speed is going to, velocity is going to be like this at this instant. Right. So if you observe, till now I had been telling you one thing. For circular motion, what is important? For every circular motion, whether you take uniform circular motion or non-uniform circular motion, what is one acceleration that is never going to be zero?
Centripetal.
Centripetal. So centripetal means the acceleration which is acting towards the center. Okay. Now tell me, you have a positive charge here. Nucleus is positively charged. You have nucleons where protons have the positive charge and electrons in the orbits which have negative charge. So these two charges do not have any physical contact, but there is a non-contact force acting between them. Will they tend to get attracted or repelled?
Attract.
So there is going to be an attractive force acting, means the electron will experience a force in this direction. Am I right?
Yes, sir.
So that force is what is technically called as, with respect to motion, that is what we call it centripetal force. So centripetal force is force which is acting towards the center. Okay. But here the important point is what is the source for the centripetal force? It is the electrostatic force. So what do I mean by electrostatic force? The force that is going to act between positive and negative charge, or between any two charges for the matter. Right. So let's say after some time the electron is here, the velocity is going to be in this direction. So at this instant, can I say that the force is going to act towards the center? Velocity is like this. At this instant, the force will act towards the center. Force will act towards the center. All these are centripetal forces. Guys, are you able to understand? So the motion of an electron around the nucleus in those circular orbits is also an example of uniform circular motion. Okay. Next time when you study, try to study with a different perspective. Don't just memorize it. Understand what are the physics behind this thing. You learn all these things in 12th standard also, in atomic structure, in atoms. Am I clear, guys? Did I answer your question of what is uniform circular motion?
Sir, how do we know that the force is perpendicular to the velocity?
Because that is the direction in which it will act. That, see, I cannot get into much technical details. Force is perpendicular to velocity. I can give you a mathematical explanation. This V is in which direction? Tangential or
Tangential.
V is in tangential direction, because you draw a tangent at every point, right? Whereas this force is acting along the radius. That's why we call it as radial. So from the properties of circles that you would have learned last year, if you join the radius to the tangent at a given point, aren't they perpendicular?
Yes, sir.
That is the reason. Okay.
Okay, sir.
So here also it is perpendicular. Here also it is perpendicular. Everywhere it is perpendicular. Okay. So this is an example of what? So the Bohr's atomic model that is proposed is an example of uniform circular motion. It's a classic example. It's a proper example for it. Okay. Now you ask me what is the example of a non-uniform circular motion, right? So non-uniform circular motion, what happens is this V will be different at different places. For example, let's imagine there is a circular track on which there is a cyclist moving. Okay. So let's take the example of your car itself, which I told you. Friend, your car, and you're sitting here and you're operating. Okay. Now what is happening? Your friend is holding the string. Now you are applying you're handling the remote control, right? Let's say at this instant, you gave the car a speed of 2 meters per second. Okay. Now what is happening? You started looking at your friend and started feeling that the car is no more moving in a straight line path. Let's say you're frustrated and you're increasing the speed of it. let's say at this instant, you increase the speed, means you're pressing the remote even more harder. So it is going to be 3 meters per second. So what has happened? So between a particular instant, the speed of the object has changed.
Sir, but wouldn't it move in a different circular path?
No, it will move on the same circle. It cannot have, how can different circles possible? Circle is a regular shape, no? Right? How is it possible that a circle can change its shape? Means, are you expecting the object to move like this? That will not happen. It is only the speed that is being controlled at different instant. That is the example of a non-uniform circular motion. Okay. So the basic difference is, in the case of a uniform circular motion, you need not worry about the speed because it's going to be constant. Whereas in the case of non-uniform circular motion, the speed, I'm using the word speed because I'm talking about the magnitude of velocity. If the magnitude of velocity at every instant is going to change, means the tangential component is going to change along with the direction, then that is an example of a non-uniform circular motion.
Sir, if the speed changes, does the friend apply more force?
Yes, it will change. It will change. If he is applying more force, then it might change. But the direction, see, if the friend applies more force, okay, then it depends. Then the path itself is going to change. Okay, then the speed might get controlled where the object starts moving in this direction. Because for me to explain non-uniform circular motion, I need to speak about forces, which I'm sure you will not have more clarity now. If you can remind me the same question in the next chapter, at the end of next chapter, you will get better clarity. If you can wait till then. Okay, if I tell you now, you will not understand.
Okay, sir.
Because I need to explain a lot of vectors. Okay, so as of now, we'll get stuck to uniform circular motion, but definitely I promise you I'll explain this. But you have to remind me. I'll forget. You have to remind me at the end of next chapter. I'll definitely do it. Okay, if possible, I'll solve a problem.
Okay, sir.
Okay. So that is it. So everyone is clear with what is uniform circular motion term? Right? So we discussed only half a page. Okay. See. So these are all the things that will get involved, for which time is not sufficient. Okay. I'll try if I can explain all these points. So, listen. I need a lot of attention, guys. See, if you take a small arc, here they have considered a semicircular arc, okay, which is a part of a circle, in which they are trying to say that there is an object revolving in the anti-clockwise direction. Okay. See, I have an alternate derivation for this also, but this derivation is the one you need to use in the exam. Okay. Now listen. Let's say when the object is at point P, its velocity is in this direction, correct? Its velocity is in this direction. But how is the object moving? The object is in, this should never be forgotten. It is in uniform circular motion. So when I say it is in uniform circular motion, if the object at this point is moving with the speed of 2 meters per second, here also it will move with the speed of 2 meters per second only. But what is changing? What is changing? I'm expecting an answer. It is
Direction.
Direction.
the direction is different. Means the way you draw the tangent at different locations is different. Okay. So at this point, the velocity is, if I call the velocity as V, I told you, right, in your textbook, whichever is represented in bold is a velocity component. So here, if you observe, this is the velocity at point P, and V dash is the velocity at point P dash. Let's say this has happened after a time interval of delta t. Okay. Now, if I draw a radial vector here, I will call this radial vector as R, and I will call an other radial vector as R dash. Okay. So if you want me to be more specific, you can make it as R vector and R dash vector, and this vector will be V vector and V dash vector. Is that clear, guys? So let me draw this diagram again. Now I want you guys to tell me. So if I take a small circular path, right? So this is the center of the circle. From the center, this is going to be the radial vector. I will call this as R vector. And there is another point Q here, which I will call it as R dash vector, right? So the speed at this point will be V vector, V vector, and the speed at this point will be V dash. Okay. And let's say the angle that it has swept is delta theta. Okay, da? Right. So if I take a separate diagram, I'll call it as a separate diagram for radial vectors. Okay, if I take a separate diagram for radial vectors, then observe CP is R vector, CP dash, okay, I'll call it as CQ. CQ is R dash vector. Then what is PQ? What is PQ, guys? So what happens?
R vector plus R dash vector.
If I call this as, let's say, R1 vector, then what shape does it take, guys? It takes the shape of a triangle. Now apply the triangle of vectors and tell me what is the concept. R vector plus R1 vector, is it not equal to R dash vector? So what does triangle of vectors state? The sum of the two vectors taken in order is equal to the third vector taken in the reverse order. So then what is R1 vector, guys? Is it not R dash vector minus R vector? Then this R1 vector is what I will call it as delta R vector. So delta in physics means change. Okay. So delta R vector is equal to R dash vector minus R vector. Is there any doubt till here? Guys, is there any doubt till here?
The radial acceleration is same as angular acceleration.
Radial acceleration is same as?
Angular acceleration.
Radial is linear. Radial acceleration is AR. Angular acceleration is alpha.
Sir, could you repeat how it's delta R vector?
I just called it as delta R. I just called it because it's a difference of two values, right? It is a difference of two radial vector. I just use the word delta because delta stands for difference.
Okay, sir.
Okay. So it is R dash vector minus R vector. So let me show
Sir,
it
is
in the
this
text.
sir, I have a doubt,
Yes,
sir.
Please.
Sir, is this the derivation of uniform circular motion?
No, it is the derivation for centripetal acceleration. And it is
Okay,
very
sir.
important. It is very important. See, this is the final expression we are trying to derive. Let me show you the final value also. This is what we are going to derive, but you need to understand this concept because there is a lot of geometry involved. There is a slightly tricky derivation of it. Okay. So till now, whatever I explained is with respect to this delta R vector. Lot of geometry gets involved in this, so please be careful with this. Okay. It's 5 already. So let's stop with this delta R vector. Tomorrow I will explain delta V and I'll complete the derivation. More importantly, I will solve few problems so that you understand things better. Okay, so today I suggest everyone to go through this concept from the textbook and look at certain examples and come. So that if you have any doubts, we can have a better discussion tomorrow. Charya. So work and come. As I told you, this is a very, very, very important concept as you keep applying it in many places. See, for example, best example is for no reason I had to explain in terms of atomic structure. See, so it gets involved in your chemistry also. So it's better you understand this concept clearly. Sharia. Any other doubts?
Sir, I have a
this?
doubt from
Please
yesterday's class.
Tell me.
Sir, in yesterday's class, we solved a problem of 4.13, sir. In that problem, could you explain how, the man took 15 minutes to cross the river?
Okay. So it is
Sir,
very simple.
the part which I understood.
Sorry, I'm not able to. Your voice is breaking. If others have no doubt, you can leave. You guys can leave.
Resultant is equal
you,
to the
sir.
velocity of man, sir.
That one you understood, no? That you understood, no? See, it is very simple. The width of the river is 1 kilometer, right? So the velocity of the man in still water means the velocity of the man with respect to river in this direction is 4. Is this point clear?
Yes, sir.
Okay. Then our job is to calculate the time. Time is equal to distance divided by speed. Observe distance and speed both are scalar quantities. So distance is how much? 1 kilometer. And what is the speed with which he is covering this distance is 4. So 1 divided by 4 gave us 0.25 hours. We know that 1 hour is 60, 0.25 is 1 by 4, 1 by 4 into 60 is 15 minutes.
Sir, but they've never given the water is still, sir.
Adanda, see, in still water itself means velocity of man with respect to river. So he told, see, this is there, no, he makes his strokes normal to the river current. So the speed with which he started moving is actually normal to the river current. So river current is in this direction. Are you able to understand? So velocity of man with respect to river. So that is what I'm saying again. Have this point in your mind. Wherever you see a man can swim with a speed of 4 km per hour in still water, it is actually the velocity of man with respect to river. Means the velocity of the man with respect to river is exactly perpendicular to the direction of velocity of river. Because they have used the word, he strokes normal to the river current.
Sir, but he doesn't move in a straight path, right? So how can we take it?
He's moving.
Velocity?
No, he is moving in this direction. What is the speed? I'm talking about speed. What is the magnitude of velocity in the direction in which the distance is covered? Is it not 4? I'm talking about in the direction of the displacement. Right? In the direction, so he's covering in the vertical distance, he's covering, like if I take, see, I understand what your doubt is. So he's going here, no, why did I take that 4? Am I right? That is your doubt.
Yes, sir.
Right. But the thing is, if I take the coordinates of this point, what is it going to be? Is it not going to be 0.75, 1? Where 0.75 is this distance, this drift, and 1 is the vertical distance. So if I take this 1 along the y direction, see, I can solve the same problem in this way. See, for example, I will say S is equal to ut plus half at square. Okay, I'll apply it along y direction. Maybe this will make more sense for you. The person is moving along y direction with 0 acceleration. There is no acceleration. Everywhere the word speed is given. So wherever the word speed comes into picture, there is no acceleration. That is an important thing. Okay, so displacement along y direction is 1. Velocity along y direction is 4 into the time taken is what you need to calculate. So time is equal to 1 by 4, which is 0.25 hours. Now does it make sense?
Yes, sir.
Got it? So that 0.25 is 1 by 2.
Yes, sir. Understood, sir.
Okay. So that is a meaning. Okay. What's it? 5, 6, I have another class. Sorry. If there is anything, you can ask me tomorrow.
Thank you, sir.
Thank you, sir.